Greetings and welcome to my channel. I'm Armin, and today's video is about thermal stress in a solid part. Metals expand when heated. Boundary conditions prevent expansion. Therefore, the metal parts undergo thermal stress. I have a 3D geometry, so I will choose 3D space. From Select Physics window, I'm going to select Thermal Stress Solid. Two physics are coupled. Therefore, heat will expand the solid body. My next step will be to click on the stationary study. Okay, I want to create a square flange. Therefore, I'm going to select a block from the Geometry tab. Also, I'm going to change length unit to centimeters. All of dimensions are optional. I need 4 holes for the screws. I will use linear array to create 4 holes. I need another linear array. After this, I will subtract the body from the 4 small cylinders. I want to define a heat source in the center of the flange. As with the previous step, I will be creating a cylinder, but in the center of the flange. Here you go. I've created a heat source in the center of the flange. Flange and heat source are 2 parts. I need 1 part. I will also cut the flange with the cylinder by selecting partition objects. We can specify the materials we need from here. I'm going to select structural steel for my part. It's time to define boundary conditions. I'm going to specify a heat source from heat transfer physics. I will enter an arbitrary number. This is the inlet of heat transfer physics. Now, I want to define an outlet. Therefore, I will add a convective heat flux for flange surfaces. In solid mechanics, we need boundary conditions. I'm going to define a wrong boundary condition to see its effect on the thermal stress. Mesh should be fine enough to show graphs smoothly. I will hit the Calculate button and wait for the solution to process. There's not enough heat to increase the temperature, so I'm entering 50 watts. I'm going to click on Compute again. Okay, stress unit is Pascal. I want to change it to megapascal from here. Stress levels are extraordinarily high, as you can see. It's artificial stress, and it's not real. If we want to use thermal analysis, we cannot use fixed boundaries, because the model becomes over-constrained. For convenience, we can create a selection name. I'm going to delete the boundary condition and add another one. Spring foundation is a proper boundary condition acting like an elastic screw. The stiffness must be calculated and entered here. The stiffness is entered as an arbitrary number. The last step is to click on the Compute button. Stress amplitude and its distribution are reasonable. I want to change the contour color. Therefore, I'm going to Color and Style and change color to Rainbow Dark. The stress distribution around the hole is reasonable. The temperature of the body can be viewed by clicking on Temperature. I'd like to see deformation of the flange, so I'm going to create a 3D plot group. By selecting Volume, we can see by default the displacement of the flange. Thank you for watching.